molecular. And the sharing of electrons forms a bond called covalent.
We
Definitely didn't? No?
No, we did.
Oh, okay. So ionic bonds, or ionic compounds have ionic bonds. Molecular compounds have covalent bonds. Now where'd they come up with that name? Well, co means to share. Valent means valence shells or valence electrons. So they're sharing the valence electrons. So that's where that word came from. Okay? Make sense? Covalent. Sharing the valence electrons. So, what does Chemistry Cat have to say about that? So, a covalent bond yells at an ionic bond. Didn't anybody ever teach you to share? Ionic bonds are mean. They only just take it. Okay? They either just take or they get bullied and they have to give to make an ionic bond. Covalent bonds, it's all about the sharing. Okay? They're the super nice bonds. Okay? Co meaning share. All right. So now, what are some notes about molecular compounds? Well, they do not form a crystal lattice shape. And you're like, well, who cares about that? Well, we care because ionic bonds, or ionic molecules, ionic compounds do form crystal lattice. So that's why it's important to know, because they don't, the molecular ones. So ionic compounds do form crystal lattice, molecular don't. Okay. And that was in our notes before, that ionic compounds do this. I was just reminding you of it. So molecules, well, let me tell you first. What were ionic compounds at room temperature? Yeah, good. So ionic compounds are always solid at room temperature, like straight up rule. Okay? But molecules can either be solid, liquid, or gas. There's not a rule about it. And they do not conduct electricity in solution. Ionic compounds, what do? They conduct electricity. So maybe we'll have to make a chart with the two, because you need to know the differences. So maybe we'll do that another day. So there's no rule for if they're solid, liquid, or gas, but there's a couple that you have to memorize of what state they are, and I'll tell you what they are. Other than that, you just got to Google it to figure it out, because there's no way to tell. Because it's important to note that the physical and chemical properties of a compound are different from those of the individual elements that make up the compound. So like, for example, Carson made the example that carbon monoxide is a type of molecular compound, right? What state is carbon monoxide at room temperature? It's a gas, and it's very deadly. It's not good. You don't want it. Well, it was made from an element called carbon, right? And oxygen. Well, carbon, we've looked at that. What's straight up carbon? Coal. The other word for it is coal. And we know oxygen, that's good. It exists as a gas. So how carbon is all by itself and how oxygen is all by itself is very different from carbon monoxide, right? That's all that statement is saying, okay? Is when you put the two together, it's a completely different thing, you know? Yeah, it's like Hulk versus Pardon?
Bruce Banner.
Bruce Banner, right? Is that what we said? Yeah, Bruce Banner. Okay. Two different things. Totally different. Kind of made of the same stuff, though. Bruce Banner, Hulk, react very differently to situations. See what I'm saying? Okay. But they're still made of the same stuff. All right. Now, a binary molecular compound, so bi meaning two, binary molecular compound forms when atoms of nonmetals form a covalent bond and become a molecule. This is really important, especially from here where it says when atoms, okay? This isn't as important of a term, but just knowing that atoms of a nonmetal form a covalent bond and become a molecule. That's a really important statement that I need you to either memorize or understand or be able to tell me in different words. Okay, so a molecule, covalent bond, and nonmetals. Those three words need to kind of stick together. Okay, nonmetal, covalent bond, molecule. Now, some elements cannot exist just as one atom and will exist as a diatomic or polyatomic form using covalent bonds. Oh, I should put that in. Cannot exist as one atom and will exist in a diatomic, so diatom, so two atom, diatomic, or polyatomic. Yep, using covalent bonds. Now, take out your periodic tables. So I say here that you have to memorize them, but if you are smart, you will find them. So look on your periodic table. If you don't have it out, and you ask me on a test, where is it? I'm not going to help you. You've got to get out your periodic table. Where is it? Okay, take one of the green things so that you can look at it. So can you find a box that says polyatomic elements?
Yep.
Yeah, so that's it. If so, when I ask you on a quiz, what are the polyatomic elements, if you just copy down what's in that box, you did it. Okay? So look here, and I'm missing astatine here, but it's astatine, bromine, chlorine, fluorine, hydrogen, iodine, nitrogen, and oxygen are all two, right? See how they're all two? So those are diatomic. Then there's the polyatomic. Phosphorus is P4 and sulfur is S8. So those are really, really, really important that you remember those. So if ever oxygen is all by itself, it has to be O2. Okay? And if we look here, where on the chart, or the table is it? Here. It forms kind of an L. So these, all of these, NOFCLBRIAT, these are all two. So you can make a note of that on your actual periodic table if you want, like highlight these and say these are your diatomics. And then here, P and S, this one has to be P4 and this one has to be S8.
So it's from nitrogen to
NOFCLBRIAT. So it kind of forms this upside down L, I guess. And then the P and the S. But like I said, you know, by the time you get to Chem 20, you have to have them memorized because you have a different table than this and it doesn't have them on it. But for Science 10, you have the table. If you want to, you can just look at it, you know? But you have to remember that for those elements, if they're always by themselves, they have to be in that form. When we get into reactions, that's really important for you to know. All right. Now, many molecules are known by their common names, such as water is H2O and ammonia, which is NH3. Now, I'm going to give you a memory sheet. So this is kind of like all your memorization things, but like I said, some of them are on your table. And oh, I didn't hole punch them, but you can do it after. It's kind of similar as your workbook, but this is just kind of, we'll put everything on this sheet, and you can kind of keep it with your periodic table as being kind of your cheat sheet kind of thing. So
So it's only obviously one business or?
it's kind of like very similar to the one in your workbook, right? But this is, I just want this one to be separate from your workbook, so you kind of tuck it in with your table and have it kind of always. So here where it says diatomic, polyatomic elements, write in, so you have this chart, write down, you know, the elements, go through, write down, you know, at first you can put nitrogen and go N2 and continue. So fill in this one using what we just talked about. All of your diatomic and your polyatomic ones. So you should be in these boxes, you write in like nitrogen N2, and then keep going. I think you might be short one box. But,
Short or have extra? I have one actually.
so you have your N, your O, your F, C, L, I, A, T, P, and S, right?
Oh, I forgot. So hydrogen is one.
Yeah. Oh yeah, so we forgot hydrogen. That also needs to be one.
Hydrogen's on there too?
Yeah, it should be. It's on your table, right? On
It's
your
not
period.
in the L.
It's not in the L, that's a good point. Hydrogen is not in your L, but it needs to, it's still included. So we need to add one more space. P4. And then S. And then you can write in the names of the rest. The AT one, we don't really see that very much in most of our reactions, but the rest you really need to remember. Okay, but like I said, it's almost like it's on a cheat sheet already for you on your periodic table.
Pretty simple.
These were acids.
Yeah, AT.
So hydrogen is 2.
Yeah, hydrogen is 2. I just didn't have enough boxes, sorry. Yeah. Okay, so you can come back to that in a minute. So we'll go on now to the rest. So now here, there are some compounds that you need to memorize. So we'll put them here on our sheet, but then I also want you to put them on your memory sheet too. Okay, so we'll put them here. So O3 is what? Do you guys know? O2 is oxygen. You've probably seen it in some of your science classes. Go ahead, Joshua. Ozone. O3 is ozone. NH3 is ammonia. CH4 is methane. And then CH3OH, so it only has one C. So one C means meth means one. This is methanol. When you see an OH at the end, that means it's an alcohol, and so it's called methanol, because it's an alcohol.
Isn't that what's like in rubbing alcohol and Listerine?
Yeah. It's a type of alcohol, yeah. And then, I don't know if I put it in your notes, I think I missed writing down ethanol. Oh no, I got it, okay. So there's C2H6 is ethane. Then C2H5OH is ethanol. This, I think I forgot to put this on your memory sheet, so you might have to add it manually. I
No,
think.
you forgot F.
Oh, I forgot ethane on your memory sheet. Yeah, okay, thank you. Yeah, so you have to add that one manually.
Where's this managed? Oh, okay.
Yeah, yeah. And then C6H12, pardon me? It's a type of sugar, we have to be more specific, it is glucose. But it is a type of sugar, but there's like so many different types of sugars, so we need to know them a little more specifically. And then C12H22O11 is sucrose. And then H2O2, do you know what that one is? The common name is hydrogen peroxide. So make sure these are filled in on your memory sheet as well. You don't have to do it right now, but after you can. So this is not like the rules of naming a molecular compound, but these are like the accepted common names that you just have to memorize. But then for everything else, I'll give you a rule of how to name everything else, okay? So these, put a star, highlight, or whatever on your memory sheet, you gotta know these ones. So these ones are not on your chart anywhere. So you have to know them. But to name everything else, here are the rules.